first do the QR decomposition, and then, after I get QR, I can solve R times X vector equals to Q transpose times B. So I form Q transpose times B, and then do a backward substitution. And in this case, because the R matrix is 2 by 2 matrix, so the backward substitution, I can just directly write down what is B and what is A. And then that returns you with the A and B. That's a solution to the B squared problem. I don't have too much time here, but let me just run this code and see what we get. So after we get A and B, the next thing I did is that I plot all the data points we measured, and then I overlay my linear regression result on top of it and see if the line indeed show the trend of those data points. So if I do that, I run it. Why does it take so long? Yeah. Move this along a bit. So you see, I have 4 measurements. Those 4 measurements are the 4 circles you can see here. They're kind of small. And now I did a linear regression. That is a dashed line, which is a line, trying to fit through all those 4 points. You know this line cannot exactly go through all 4 points. So if it does, that means that means the system has an exact solution. So in this case, you see this line pretty much captures where all those points are, and pretty much go through them. And if in the type of this plot, it returns you what the line should look like. So in this case, it's pretty much y equals to 2x plus 1. That is actually the line set. So I want something to be 2x plus 1, and then I pretty much make out all those 4 data points around this line, so that I can test if my linear regression works here. And theoretically, this code should work for other data. Like for example, if you have different measurements, you have x and y that's longer than this and shorter than this, that's fine. You should be able to do linear regression with this code. So that's it for today. And when you go home, make sure to play with it and see if you can, with some data you have from other class, if you can do linear regression. If you can do it, then I did linear regression myself.